Imagine for a moment you're floating in space completely alone when suddenly you notice something impossible to grasp. A region where stars simply vanish, where light itself is swallowed by a force so intense it defies everything we know about reality. You're looking directly into a black hole, and in a matter of seconds, the most extreme journey any conscious being could ever experience will begin. A journey that will test the limits of physics, time, and existence itself. Today, cosmic explorers, let us embark together on this impossible voyage and discover what would really happen if we fell into a black hole. From the very first moments to the most bizarre consequences science can imagine. Hey there, cosmic explorers. Welcome back to Cosmic Frontiers, where we turn the universe's deepest mysteries into adventures of discovery. Today, we experience something no human could ever survive to tell about: falling into a black hole. We'll find out why Einstein was so rattled by these scars in the fabric of space-time, how Stephen Hawking revolutionized our understanding of them, and why black holes are considered the universe's most extreme natural labs. Get ready for a journey where time stretches, space bends to the extreme, and the laws of physics hit their absolute limit. Oh, and don't forget, we're building our crew towards 1,000 cosmic explorers, so come join us on this adventure. Our journey kicks off long before we even get close to the black hole itself. Imagine you're a brave, or maybe reckless astronaut who decided to check out Sagittarius A*, the supermassive black hole at the center of our galaxy. With a mass equivalent to 4 million suns packed into a region smaller than Mercury's orbit, this cosmic giant is a real gravitational beast. But here's the first surprise. Unlike what many sci-fi movies show, you wouldn't be immediately sucked in by the black hole. In fact, millions of miles away, you could orbit it safely, just like a planet orbits a star. A black hole's gravity works exactly like the gravity of any other massive object when you far enough away. If the sun were magically replaced by a black hole of identical mass right this second, Earth would keep its normal orbit. It would just get super cold. Think of it like someone dancing around a giant whirlpool. As long as they keep enough distance, they can spin in perfectly safe circles. The real danger starts when we decide to get too close. As you steer your ship towards the black hole, something extraordinary starts happening to the time around you. This is one of the most bizarre and well-confirmed predictions of Einstein's general theory of relativity. The closer you get to an intense gravitational field, the slower time passes for you compared to the rest of the universe. It's like you're diving into a deeper and deeper time. Well, to get this, imagine two twin brothers. One stays on Earth, watching through a super powerful telescope, while the other embarks on this suicidal journey towards the black hole. For the brother who's falling, everything seems normal. His watch ticks normally, his breathing is regular, his thoughts flow at their usual pace. But for the brother on Earth, something impossible is happening. He sees his astronaut brother starting to move in slow motion, like someone hit the slow-mo button on a movie. This time dilation is science fiction. It's a measurable reality we experience on a small scale every single day. GPS satellites constantly need to adjust their clocks, because they experience time slightly faster than we do here on Earth's surface, due to the difference in the gravitational field. Now imagine that effect amplified trillions of times near a black hole. It's like the very fabric of time gets thick like molasses as you approach this cosmic anomaly. But the real adventure begins when you cross what scientists call the event horizon, the ultimate point of no return. Carl Sagan once described it as the edge of forever, and that description is chillingly accurate. The event horizon isn't a solid physical surface, like the surface of Earth or the Moon. In fact, if you could look at it up close, you wouldn't see anything special, just empty space. It's more like an invisible boundary in space, like the equator. It exists. It has huge consequences, but you can't see it or touch it. For a black hole like Sagittarius A*, this event horizon is roughly 24 million kilometers across. That's bigger than Mercury's orbit. Once you cross that invisible line, something fundamental changes in the universe. All possible paths you can take lead inexorably to the center of the black hole. It's like being in a cosmic waterfall where the current has become so strong that there is no way to swim against it anymore. No matter how powerful your spaceship engines are. Here's something that's gonna blow your mind. The exact moment you cross the event horizon. From your perspective, nothing dramatic happens. You don't feel a barrier being crossed. there's no sudden change in temperature or pressure. If it weren't for your instruments telling you your location, you might not even realize you just crossed the most definitive boundary in the universe. It's like crossing the equator during a flight, a moment of enormous cosmic significance that goes unnoticed in direct experience. But for that twin brother who stayed on Earth watching, for him, something very different is happening. Due to the extreme time dilation, he sees you slowing down drastically as you approach the event horizon. Your movements get slower and slower. Your image gets redder and redder due to gravitational redshift, where light itself is stretched by intense gravity, and eventually, to the external observer, you appear to freeze exactly at the edge of the event horizon. Your image slowly fading as the light coming from you becomes impossible to detect. For him, in a way, you never truly enter the black hole. You just disappear at the boundary, like a cosmic ghost. This is one of the deepest and most unsettling dualities in modern physics. Two completely different and seemingly contradictory descriptions of the same event, both perfectly valid depending on your point of view. It's like the universe has two simultaneous versions of reality, and which one you experience literally depends on where you're standing in the cosmos. Now, let us get to what is perhaps the most terrifying and fascinating aspect of our journey: spaghetti. This term, which sounds like something out of a comedy movie, describes one of the most violent processes a body can experience in the universe. Imagine you're falling towards the center of the black hole in a vertical position, with your feet pointing down. The gravity your feet experience is significantly stronger than the gravity your head experiences, simply because your feet are a few feet closer to the center. Under normal conditions, this difference would be negligible, but near a black hole, where gravity can be trillions of times more intense than on Earth, this small difference in distance creates a devastating tidal force. To visualize this, think about how ocean tides work on Earth. The moon pulls the ocean water closest to it with more force than it pulls the solid Earth below, creating a bulge of water. Now imagine that same principle amplified to absurd levels. Your feet are pulled towards the center of the black hole with an increasingly greater force than your head, creating a tension that literally stretches your body like spaghetti, hence the name spaghettification, or more technically, differential tidal force. To visualize this, think about how ocean tides work on Earth. The moon pulls the ocean water closest to it with more force than it pulls the solid Earth below, creating a bulge of water. Now imagine that same principle amplified to absurd levels. Your feet are pulled towards the center of the black hole with an increasingly greater force than your head, creating a tension that literally stretches your body like spaghetti, hence the name spaghettification, or more technically, differential tidal force. But here is something surprising. The size of the black hole makes a dramatic difference in when this happens. If you fell into a stellar black hole, formed by the collapse of a massive star, with about 10 solar masses, you'd be spaghettified long before crossing the event horizon. It would be a quick death, but definitely not an experience you'd survive to tell about. However, if you chose our destination of Sagittarius A*, the supermassive black hole, something almost miraculous happens. Due to its immense size, the event horizon is so far from the center that the tidal forces in that region are relatively gentle. You could cross the event horizon completely intact and conscious, like a cosmic explorer crossing an invisible boundary. It's like the difference between falling into a small, steep waterfall versus a giant, gradual waterfall. In the small waterfall, the height difference creates violent turbulence very quickly. In the giant waterfall, you can float over the top edge without even realizing you're starting to fall. This is one of the most beautiful cosmic ironies. The most massive and dangerous black holes in the universe are, paradoxically, the places where you'd survive the longest during the fall. As you continue your journey towards the center, passing through regions where no human has ever been or could survive, you become a witness to phenomena that test the limits of what physics knows. The space around you is no longer the familiar void we know. Near the center of the black hole, the very fabric of space-time is bending in ways that defy our intuition. Imagine trying to draw a triangle on a piece of paper, that S being folded and twisted into dimensions you couldn't even visualize. That S, how the geometry of space behaves under these extreme conditions. And then we get to the real mystery, the heart of the enigma that keeps theoretical physicists up at night. What actually exists at the center of a black hole? The math of general relativity predicts something called a singularity. a point of infinite density, where the laws of physics simply break down. It's like dividing a number by 0 on a calculator. The result is undefined, a sign that our equations have hit the limit of what they can describe. But do singularities really exist in nature, or are they just signs that our current understanding of physics is incomplete? Some scientists propose fascinating and speculative theories. The firewall hypothesis suggests that the event horizon would be a wall of energy so intense that it would instantly vaporize anything that tried to cross it, turning our serene journey into an instant death by incineration. Other theories suggest that the interior of a black hole could be connected to other regions of the universe through cosmic bridges called wormholes, or even be portals to completely different parallel universes than our own. String theory, one of the most ambitious attempts to unify all the fundamental forces of nature, suggests that when we get close to the singularity, microscopic quantum effects become dominant, potentially creating a complex structure of extra dimensions where our journey would take completely unimaginable turns. It's like finding out that instead of reaching the end of a road, you've actually found an on-ramp to a multi-dimensional highway system you didn't even know existed. But perhaps the deepest mystery of all is the black hole information paradox, discovered by the brilliant Stephen Hawking. Hawking showed that black holes aren't completely black. They emit an extremely faint thermal radiation, now known as Hawking radiation. This radiation causes black holes to slowly evaporate over incredibly long times. A black hole with the mass of the Sun would take longer to completely evaporate than the current age of the universe, multiplied by trillions of times. But here's the paradox that obsessed Hawking for decades. If a black hole completely evaporates through Hawking radiation, what happens to all the information that fell into it during its existence? The laws of quantum mechanics say that information can never truly be destroyed, only reorganized or encoded in different ways. But Hawking radiation seems to be completely random, with no connection to what originally fell into the black hole. It's like burning an entire library and finding that the ashes contain no trace of the books that were destroyed. This paradox touched on fundamental questions about the nature of reality. Can information really be destroyed? Is our understanding of quantum mechanics incomplete? Or do black holes work in ways we don't yet understand? Recently, some physicists have proposed that the information that falls into a black hole might be holographically encoded on the surface of the event horizon, like a three-dimensional hologram encoded on a two-dimensional surface. Others suggest that the information leaks slowly through complex quantum correlations in Hawking radiation, in ways so subtle that we haven't yet developed the tech to detect them. As we contemplate these deep mysteries, our hypothetical journey reaches its end in ways that science cannot yet predict with certainty. Maybe you reach the singularity and simply cease to exist in any form we can comprehend. Maybe you become part of an exotic quantum structure that obeys laws of physics we haven't yet discovered. Or maybe you emerge somewhere else or sometime else, carrying with you information about regions of the cosmos that are forever beyond the reach of direct scientific observation. What we know for sure is that your journey would represent the most extreme possible exploration of the limits of known physics. You would have witnessed phenomena where gravity, time, space, and information itself behave in ways that challenge our most fundamental understanding of reality. It would be like being the first explorer to map territories that exist on the frontiers between the known and the unknowable. Black holes teach us cosmic humility. They show us that even after centuries of scientific progress, even after sending probes to the far reaches of the solar system and detecting gravitational waves from distant cosmic collisions, there are still regions of the universe where our best-tested theories hit their limits. They are living reminders that the cosmos still holds deep secrets, mysteries that may require complete revolutions in our understanding of physics to unravel. Cosmic explorers, we've just experienced together the most extreme journey the human mind can imagine. We've discovered how time stretches almost to a halt, how space bends beyond imagination, and how the very foundations of reality behave under conditions that test the absolute limits of physics. We've learned that a fall into a black hole would be simultaneously the most personal and most universal experience possible. Personal because it would be your individual journey through unique phenomena, and universal because it would touch on the most fundamental questions about the nature of space, time, and information. More importantly, our exploration revealed that black holes aren't just the most extreme objects in the universe. They are windows into understanding how reality works at its deepest levels. They connect the most familiar force in our daily lives, gravity, with the most abstract mysteries of quantum mechanics and the nature of information. They are cosmic labs, where the universe conducts its own experiments at the limits of what's possible. This journey we shared today raises a profound question. What does it truly mean to exist in a universe where such extreme phenomena are possible? Each of us is made of atoms forged in the heart of stars that lived and died billions of years before we were born. We are literally conscious stardust, contemplating the cosmic mysteries from which we emerged. And perhaps the most beautiful lesson from black holes is this: even in the most extreme and seemingly hostile places in the universe, we discover reflections of the same fundamental laws that govern our existence here on Earth. Now, I want to hear from you, cosmic explorers. If you could ask a black hole one question, if you could somehow get an answer from this cosmic mystery, what would you ask? Write in the comments what aspect of this journey sparked your curiosity the most, or share your own theories about what might exist beyond the event horizon. And since we're talking about universe mysteries, what other extreme cosmic phenomena would you like us to explore together? Suggest topics for our next videos. Maybe neutron star collisions that create all the heavy elements in the universe, or the first fractions of a second after the Big Bang, when time and space themselves were being born. We're rebuilding something special here at Cosmic Frontiers, a community of curious minds, united by a passion for understanding our place in this magnificently mysterious cosmos. We're on an incredible journey towards 1,000 cosmic explorers, and every new member of this crew brings us closer to unraveling the universe's deepest secrets together. If this video expanded your cosmic horizons, if it made you look at the night sky with more wonder and curiosity, join our expedition by clicking subscribe. Like this video if it inspired you to think about the limits of reality, and share it with someone else who's also fascinated by the mysteries that surround us. In the next video, we'll explore another phenomenon that challenges our understanding of the cosmos. Until then, keep looking at the stars and questioning everything.